All right, 3.2, maximum and minimum. Other terms that we use for maximum minimum are absolute maximum or minimum, absolute extrema, and extreme values. Now, when we ask for absolute extrema, they usually are absolute extrema points. When we say extreme values, what I'm looking for are the y values. And they would be considered either a max or a min. So please, when I ask for extreme values, you will tell me whether it's a max or a min and the value that it's at. The absolute maximum or minimum of a function will occur at when the derivative is equal to 0. So when f prime at some value c is equal to 0, or at an endpoint. Now, a maximum obviously means the highest, and the minimum means the lowest. So the idea is that if you ask for a max or min, you want to take the derivative of the function and set that derivative equal to 0 to determine, and also set the derivative equal to 0 to find the value when it's equal to 0, and also to test the endpoints to see whether you have an absolute max or min occurring. Now, step 1, calculate the derivative. Set the derivative equal to 0 and solve for x, also known as a critical point. And number 3, calculate f at x for the values in question number 2 and the endpoints, meaning that I'm going to plug in the values that I found in question number 2. So all the values where the derivative is equal to 0 and for the endpoints, plug those into the original function f and compare those values to find the max or min. All right, let's try an example. Example 1. Determine the absolute extrema of f at x is equal to 2x cubed minus x to the power 4 for the endpoints x belonging to from negative 4 to positive 3. So what you have to do, just like it said earlier, is step 1, find the derivative. Step 2, set the derivative equal to 0 and find what values the derivative is equal to 0. You find out the derivative values are x equals 0. Oh, let's try that again. 1 second. Okay, so we set the derivative equal to 0, solve for x, and you find out that x equals 0 and 3 over 2. And you also have to test the endpoints, which are negative 4 and 3. So we test all of them, negative 4, 0, 3 over 2, and 3. Why did I choose those values in that order? Remember that whenever we look at something in terms of the values, we always test from the smallest to the largest number. It's just a practice that you get into, and if you do that, you just know that you meet every single point. So you find out that going along, you find out that there is a absolute minimum at negative 4 and negative 384, and an absolute maximum at 3 over 2 and 27 over 16. These are considered extrema points. Let's say I ask for extrema values. You would say then the absolute minimum value is negative 384, and the absolute maximum value is 27 over 16. So just so that you have the idea, if I ask for extrema points, this is what I mean by points. And if I ask for extrema values, this is what I mean by values. Just keep in mind what the question is asking. Next, example number 2. Determine the absolute extrema values of f at x is equal to 2x to power, extrema points or values of f at x equals, okay, just 1 second. Okay, so determine the absolute extrema for f at x is equal to 2x to the 4 minus 4x plus 4 for these x values. So determine the derivative, set the derivative equal to 0, solve for x, and you find out that x has these values, 0, negative 1, 1, and we're going to test the endpoints, but notice something that gets crossed out. Why does positive 1 get kicked out of our test? Well, let's look at the restricted domain. It says find between the values of negative 2 to a half. This value is greater than a half, so this value does not get considered. These values are all within the domain, so they get considered, but plus 1 is not considered, so it gets crossed off. Okay, so it's not within the restricted domain. Determine the values in order, and you get these values. So the absolute maximum value is 20, and the absolute minimum value is 2. Just to keep in mind, if I ask for a value, you would write that. If it's coordinates, you make sure you give me the x and the y. All right, one more. Example number 3. Find the value of k if the function y equals x squared plus kx plus 72 has a local minimum at x equals 4. What does that mean? Well, if it has a local minimum, it means the derivative of this function is equal to 0 when x is equal to 4. So you take the derivative, and then you sub x equals 4 and y prime to equal 0. What you do is you can solve now for k. Lucky for us, it's a very simple calculation. Now let's say it says find the value of k. So we found the value of k. That would be the answer right here. So no problem. What happens if it said find the coordinates? Okay, so you would have to plug it in, the value, once you found k, and the coordinates turn out to be, lo and behold, 4 and 56. All right, that's everything, folks. That's the end of 3.2. See you tomorrow.